Hello again, this is Mike Gidding from Third Eye Geoscience. I teach a workshop called A Modern Approach to Seismic Interpretation, in which we learn how to deliver high-quality seismic interpretation in an efficient manner using the Petrel suite. In the workshop, we learn how to create a structural framework and volume-based model from our seismic interpretation, and the benefits of these models at just about any scale of interpretation project, from 2D exploration through to detailed development work. We also learn how to interpret in a modelling compliant fashion. One of the benefits of these models is that the interpreter has control of the structural story all the way up to the creation of a geocellular model. This is in stark contrast to the conventional route of an interpreter handing over a set of surfaces and fault sticks to the geomodeler, who will very often have to whittle away at the faults to get a well-behaved model. It's a long and frustrating process. Creating a Depogrid from a volume-based model involves a few simple steps. Unfortunately, they require quite a bit of compute time, so I don't teach them in the workshop. In this video, we will skip the compute time and I'll walk you through the process. In summary, first we run the depot space calculation, then create a Depogrid, and finish by using the geometric modelling tool to display the geological layers. Let's have a look. To build our volume-based model, we start with a set of fault sticks and a set of horizons. Then we create a fault framework that might look something like this, and eventually we end up with a zone model that looks like this. To get to a Depogrid, the first thing we need to do is create the depot space calculation. So if we open up the depot space calculation dialog box, you can see that it's pretty straightforward. We put a top and a base in, and if we want, we can apply boundary conditions. That will stop the depot space model exceeding the limits of our current boundary. Now the trick here is turning the tick on doesn't actually do anything. To create a hard boundary, you need to actually click on each of these surfaces that you want. Okay, so once we've decided whether we're going to create a boundary or not, and we've given it a top and base, we can just hit OK. And the result will look like this. Same information but displayed in a way such that each conformable surface sits horizontally. And you can see the effect of the truncation at the base of the pink zone here. So that's a depot space calculation, and that takes quite a few minutes to run. The next thing we want to do is move into the structural gridding. So if we click on structural gridding, you can see here that the dialog box is also pretty straightforward. So if we create a new grid, what we need to do is feed it a structural model. So that's easy, we just saw that. We click on the structural model, the little arrow goes blue, we pop it in, and all of our horizons pop in down the bottom here. So we want to change our gridding technique from stair-step gridding to Depogrid. That makes the dialog box even simpler. The only thing we can really change here is the size of the grid and the number of layers for each of our zones. So for example, if we slide that out of the way for a moment, you can see here that the pink zone in here is very skinny, as is the red zone up the top and the other pink zone down the bottom. So it doesn't make much sense to create those with as many layers as the others, so you might want to go in and change those to 5 and 5 and the layer below the big unconformity there is quite thick, so we might change that to 15. And if you had an objective section, you might want to increase the number of layers through that as well. So once we've done that, all we need to do is hit OK. Again, that takes some time to calculate, and in the end we will get something that looks like this, which is called a cell index. So you'll see now that you've got a Depogrid sitting in here, and underneath there you'll get two properties, cell index and regional fault blocks. We'll come to the geological layers in a minute. So under cell index we'll get something that looks like that. If we change the property to regional fault blocks, we can see all of the different fault blocks that it derives. And if we want to generate these geological layers, what we need to do is go to the geological modelling, geometric modelling I should say. So under geometric modelling we can change the method to zone index and then choose all geologic layers. That's all we need to do. We hit OK, And then our geologic layers become available, and you can see that's looking much more interesting and more like a cellular model. So now the last thing to do here is to put the cells on. That's simple as well. Double click on the properties to get the settings for the properties and turn on the grid. Hit OK. And there we have it, a Depogrid that we're very happy with, and we can proceed to other sorts of modelling. If you have any questions about seismic interpretation training, please get in touch at Third Eye Geoscience.